everyone, today we will start 6.7. Okay, in the 6.7 it is a modeling of a logarithmic and exponential functions. So in the first question, what is given? We are provided by some values and we have to identify what type of function is this. So x values are changed continuously. Y values are changed in this way. See how 0.5 changed to 1. Either I add 0.5 or I can multiply by 2. How 1 changed to 2? Only multiply by 2. 2 changed to 4, multiply by 2. Then again multiply by 2. So that means the multiplication factor is there. If there is a multiplication, that is an exponential function. So you will say it is a exponential function. Okay. Now see the B part. In the B part, x are changing continuously. Okay. How the y change? 2 and 0, then 2. It's not a multiplication because if it is a multiplication, if one of the term is 0, next term must be 0. So let's find the difference. 0 minus 2, it's minus 2. 2 minus 0, it's 2. 8 minus 2, 6. 18 minus 8, it's 10. 32 minus 18 is what? 14. 50 minus 32 is 18. This is not same. Each difference is not same. Now, whatever the difference you got, again find the difference. That's a second difference. 2 minus of minus 2, 4. 6 minus 2, 4. 10 minus 6, 4. 14 minus 10 is 4. And 18 minus 14 is 4. So second difference is same. Therefore, these table values are representing a quadratic function. It represents a quadratic function. Quadratic function. So in the second question, let's see the next one. We have to write an exponential function. How the function is? Y equals to a b power x. A we don't know, b we don't know. But we are given that this function is passing through these points. 1, 6 and 3, 54 are the points from which it passes through. Passes means it will satisfy the equation. So let's substitute. This is x, this is y. So 6 is equals to a b power 1. This is x, this is y. 54 is equals to a b power 3. I can divide both sides. Divide that. Left side divide by left, right divide by right. Okay. 6 and 54. 9. A and A cancel. B and this will be cancelled. 2b left. 9 equals to b square. So you get b square is 9. If b square is 9 and we know that b is always a positive number greater than 0 and not 1. So negative is not possible. So only possibility is 3. So you got b is 3. As you got b3, substitute b value here. You will get 6 equals to a 3 power 1. A is 6. A is equals to 6 by 3. We are getting A is 2. So A is 2, B is 3. What's the function? Your original function was y equals to 2, 3 power x. Done. This is the answer. Next question. See. Here it says that a store sells trampoline. The table shows the number y of trampoline sold during the xth year that the store has been open. Write a function that models the data. So here how it's given. The number of years are continuous increasing. There is no a problem with x. Now see, 12, then 16, then 25, 36, 50. These are not continuous change. Okay, there is no continuous change. So I will try to draw a model. So if I write that, is anything work well here? So if let's see, I will draw it. Then we can identify what is the type of the function. 2, 4, 6, 8, 10, 12. If I change into 4, 4, 8, 12, 16, 20, 24. It's like this. 1, 2, 3, 4. Add 1, it's 12. Add 2, it's 16. Add 3, it's 25. It's a very high. So it's not a linear. So it's going like upside. So it's an exponential function. Every exponential can be written as a y equals to a b power x. To find the original function, I will use the values. I'm using the first value. At 1, the answer is 12. So y value is 12 if you put x to 1. Now choose the next one. The value of a, if we have to calculate. So x is 2, y is 16. 16 equals to a b power 2. Divide the both functions. 16 by 12 is equals to ab square over ab. A and a cancel. 1b and 1b cancel. You left with here 4 3s are 12. 4 4s are 16. 4 over 3. We are getting 4 over 3. If I write 4 over 3 in a decimals, or you can keep a b as a 4 over 3. Okay. As you get b, substitute b value here. 12 is equals to a 4 over 3. So multiply. 12 into 3 is equals to 4a. Divide by 4. You will get 3 and a 3. 3 3s are 9. So a value is 9. What you will get? Y equals to 9. 4 by 3 to the power x. I choose these first two values. Okay. If someone is doing there, you can use another value. In that case, your graph, your values will be approximately same. Not exact same. It will be approximately same because the graph is not a complete proper exponential. They have some different values. As we know that 2 power x is a graph, right? We know the values. But the values is like 1.23 the power x. For this case, the values are not exact integers. You will get some decimal values here and there. But if you take round off, it depends on. Okay. Next question. Use the data from the example 3. Okay. Create a scatter plot of the data pair in x and log y. We need a calculator here. Let's write what are the values here. What are the values we have? We will convert these values into log y, not y. They want natural log of y. So let's calculate its value. I have to calculate 12 log. It's 2.48 approximately. 2.48. For the next log of 16, 2.77. Log 25, 3.21. Similarly, I will calculate these values also. You can check this. I draw all points in a graphing calculator. I use Desmos. So I will just take this picture for the question. So what type of coordinates it look like? It look like a straight line equation. Okay. So it's like this. In this straight line equation, we have to find the equation of line as well. So I'm choosing the first point and the last point to find the equation because it says write a exponential model. It's a straight line look like. In our case, this is not y. This is a log y. And how the equation of a straight line is y minus y1, but it is a log of y minus y1 equals to the slope m x minus x1. So I choose the first number as a 1 comma, it's 2.48, and the second is a 7 comma 4.56 log of y minus. So the value here at y1, I'm writing the value of y1. The y1 value is this. So this is a log y value. Okay. So 2.48 is equals to slope. So using these two values, difference of these two over difference of these two. You can check this. I find the difference of y values over difference of x values. I'm getting 0.3466. If I round off up to 2 decimal places, it's a 0.35 times x minus x1. That's what. So for this case, I will solve for log y. Log y equals to 0.35x minus 0.35. This term will be shifted other side to get plus 2.48. Now solve it. 0.35 here plus x plus here 2.13 log of y. And I want y, not log y. So taking exponential both sides, e power 0.35x plus 2.1. I can separate this by writing e power 0.35x times e power 2.13. You can calculate this e power 2.13. It will becomes out 8.41 e power 0.35. So you can calculate e power 0.35 also. It will look like 1.42 x to the power x. This is the other function model we got for exponential function using this. We convert the given values into log. Then I find the equation of line because according to the log it's a straight line. So I find equation of a line and then convert log y value into y. And we got exponential function again. Okay. Now see this. Here in this we will find a one function. Here I find another function for the same values. Now I have to use regression calculator to calculate another function using regression model. So I am using the Desmos again. Let's see. So see how I write. I write the x values here, y values here. It's not log y value, it's a y values now. And here I write a function. Y is approximately a b power x. Exponential function we are looking for. So I write in this way. So what I got? Using these values, I got a value is 8.97 and b value is 1.40. You get this by regression calculator of exponential. Let's write this one. Okay. So here, this is your function. Y is approximately 8.9 into 1.40 to the power x. So this is the predicted model for the given values. So all three values you can see. This is with this example. With the previous example I got this function and the before that I got this function. I'm telling you, if you use the different value you will get a different answer, but it will be almost the same. Approximate same values will be get in a decimal, difference of a decimals only. Alright, so next question. Now we have this question. The atmospheric pressure decreases with increasing altitude. At a sea level, the average air pressure is 1 atmosphere, which is this kilometer per square centimeter. The table shows the pressure at selected altitude h. Use a graphing calculator to find a logarithmic model. How the model will look like? H is equals to a plus b log of p. In the model, in the same, I will write y1 equals to a plus b log of x. These are the x value. I will consider this as a x value. This is considered as a y. Okay, let's find out. And using this, we have to find the estimate the altitude when this is the pressure. So first we will find the model. So say this. I write the values, then I define a function here. Y approximately a plus b log of x1. So I got the value of a, I got the value of b. So I want these two values only to define a function. Okay, let's write it. So your function is y 0.86 minus, because b value is minus 6.45. I round up to two decimal place, log of x. So this is the model, logarithmic model using this. And from here we have to calculate the altitude when the pressure is 0.75. This is the h and this was p. Okay, this is p and this is h. So substitute p as a 0.75. 0.75. Remaining terms as it is. So what you will get? You will get it's approximately 2.7. Units are a kilometer. So height is 2.7 kilometer. Done. Okay. So we have covered 6.7 today. I hope you understand that everything in this chapter was modeling for exponential and logarithmic. Chapter 6 is completed. In the next video, we will start a review of chapter 6. Thanks for watching.